Hello and welcome, fellow colleagues, students, and anyone that is watching this video. Thank you all for being here, and it's my pleasure to be presenting this Visual 3D workshop for you. So, for those that don't know me, my name is Dr. Abdurrahman Wattas, and you can call me Abdu. I been here at the Department of Biomechanics at UNO, and now recently we became a division. Since 2016, I did my master's and PhD here, and it was just a wonderful experience to learn all of these amazing biomechanical knowledge from this just one of a kind in the planet. So this is gonna be a visual 3D tutorial from just the very basic to those that never use visual 3D, so complete beginners, all the way to very advanced methods to analyze biomechanical data. So Visual 3D, V3D in short, as you can see here, this software is a biomechanical software used to visualize biomechanical data in 3D and do a very wide range of biomechanical analyses that whether are already available in literature or just anything you want to do new, or if you have like a new biomechanical model, anything you want to do. Although it's not very open and malleable and flexible as MATLAB, it is a very powerful tool to be used in biomechanical data analysis. So this specific video is going to be a short video to introduce you to just the basics, the very basics of Visual 3D and how to get started. So let's open it up. This is how it looks. This is the most recent version, the student version edition. Visual 3D is a professional software, so it's very expensive. I believe the first license will cost you around $4,000, and then any additional license to any lab will cost half, so $2,000 per each additional license. So this is what it looks like. We have the workspace in here where any data that you load in will be visible in here. And then if you click in here, there's the signals and events data. This is where you will see your actual biomechanical data, and this is where you can run all of the data analysis, biomechanical data analysis. Here's the model panel where you'll see your biomechanical model in here. Obviously we don't have anything in here, so it just shows you the orientation. Here shows you the reports, and if you want to use it in real time, you can go to this panel. Okay, so let's start with the basics, the 101, the introduction. So once you collect your data, once you analyze, once you process your data, and whether any specific biomechanical software, like this is Cortex, which is Max software, so motion analysis corporation, but whether you're using Vicon, it's going to be Nexus, or Qualisys, or QTM, whatever the biomechanical software you're using. Once you process your data and then you export it in C3D format, in here you'll need to load it into Visual 3D. So the first thing you want to do, if you have anything in here, like, you just need to click new, but since we don't have anything, you either go to file and then open add, or you can click on this yellow folder tag and that says open, then you just click on it and then you can open your data. I have plenty of data that I can play around with. Like, let's see any any data here. So here, the first thing is you need to only open your motion capture data, not the static calibration. We'll get into that in a little bit. So you open up your actual data that you want to analyze in here, and you will see it in the workspace. So here we have all of our data, as you can see here. But if you open it, you're not gonna see anything. I mean, you will see the markers, but that's it. That's about it. So you'll see the markers, you'll see the ground direction forces, but you're not gonna see the actual skeleton, because when we go to the model, we don't have anything here. So the next step is to go to the model panel here section, and then click on create, add static calibration file. And this is, again, it's very basic Visual 3D for beginners, like if you've never used Visual 3D. So that's why we're doing everything manually, but we'll get into the automative pipeline generations in a later stage. So you go to model, create, add static calibration file, and then click on hybrid model from C3D file. It will take you to any, no, you can add anything, but obviously it has to be the static calibration corresponding to that specific participant. And also, if you're running multiple sessions, like if you're doing an intervention or a clinical trial or so on, you'll need to make sure that you add that specific static calibration from that certain relative session. You can add, if it's the same participant, you can add a different static calibration from a different session. However, it's going to be slightly different, so it's not going to give you accurate and perfect data. So we go in and add our static calibration, and here you have to add that static calibration to the motion files. So I'm going to add that static calibration to all of them, and then here we go, we have it. But of course, we're missing the model. So here you'll have to create your own model depending on that specific marker set that you used, and we'll get into that shortly. But assuming that you already created your model, then you go again to the model section and either append model template to current model or apply model template. Both of them work, but this is the preferred one, apply model template, and then we add in our specific model. So here I created one already, of course, and then you will have your model in here. When you go to the signal and events section, you'll see here now you see there's a mistake here during the data processing. Something happened, and well, like a mistake happened by anyone that was tracking the actual data, and you're gonna see this, you'll encounter this when you collect your data. So the problem here is that obviously, like, we're not gonna use this data, you have to go back and correct it. But here, one, like, this is the left knee and this is the right knee, and it's actually correct, but probably one of these markers was wrong. See, like this is the right shank, and these are supposed to be the left shank cluster markers. So then what happens here is that you have to go back to the actual data and then correct it, but this is obviously not usable. But these markers, because they're named, they switched, the left should have been on the right and the right should have been on the left. That's why you see the shanks on the opposite side. But also because we're missing the markers on the pelvis, you don't even have a pelvis. So this is what happens, when you have wrong data. Now this is what it looks like. You'll notice that here the shank is correct, but the femur is a little bit downward, and that's because the shanks, if you see the shanks in here, the clusters of the thigh were a little bit below what it was supposed to be compared to the actual model here, and that's why the shank is a little bit lower. So you also have to make sure, like during data collections, that you have the clusters or whatever, like calibration, tracking markers that you use are correctly placed. Here, because the shanks sometimes, during collections, if they're not tight enough, they'll go down. But it's not a major problem because in biomechanics, to create a segment, you need at least 3 markers. So here we added a shank, the clusters for the shank, for the thighs, for the upper arm, and for the forearms to improve the segment creation, especially for the arms, because when we move our forearms, it gets complicated if you only add 1 marker. But for something like this, it's not a major problem, but it's not ideal, of course. All right, so that's Visual 3D 101. In the next chapter, we'll go into and dive in on the methods to create these models. All right, thank you for listening. See you later.